What is our last class discussion?
Guide and sweep.
Guide, guide and sweep. Is it
Fine, fine.
is it correct? Any
Fine.
sweep command available in Catia?
No.
Then just recall the name of commands which we discussed in the last class. Are you remember anything? Hello? Are you remember something? What we discussed in last class? Hello Mohit, Kishan.
Guide and spine, sir.
Guide and spine is any command? Such command available?
Multi-section solid.
Uh,
Multi-section solid.
multi-section solid. I think all options of multi-section solid we discussed. Is there any command of sweep in Catia? Is the sweep
Sweep
command is
not.
sweep command is available in Catia? Hello.
It's rib.
Is the correct name of sweep in Catia? What is the correct name? Hello. I think all are
Multi-section solid.
multi-section solid is fine. But what other commands we talked?
Rib, sir.
Reap, correct. So multi-section solid, in that what we discussed, requirement of multi-section. What is that? Multiple cross sections we are going to create, then guide, spine, coupling. Okay. Then we talked about shell command and stiffener. They have two types in it, from side and from top. Okay. So this is our today's uh, classroom assignment. Soap case, which is a product generally familiar to you. In day to day in our life, we will use this product, soap case. Okay. So by taking this example, today we are going to talk regarding these topics: Boolean operations, multi-body concept and relation. Then in that, what Boolean operations we are going to talk today? Only basic Boolean operations. These are three types of Boolean operations: add, remove, and intersect. Intersect is a new thing. Already add and remove you learned in NX software also. But intersect is new add-on in this Catia. We will discuss it today here. Okay. So generally, these tools you already used in NX. Can anyone tell what is the reason to use the Boolean operation when you decide to go for Boolean operation? By considering your previous knowledge of NX, can you give the answer?
Unite.
But what is the purpose to use such a unite, remove, for which products we are going to take these Boolean operations?
Forging component.
Not forging, not forging.
Casting,
Casting and
Machining.
not machining. Generally, casting and plastic modeling purpose. We are using this Boolean operation because creation of course in the Boolean operation is quite easy. You already know in NX software. We are using a methodology there, core bodies, separate group, and unite body separate groups. Okay, so the main reason for that is to create the casting and plastic products. That is what the application of this Boolean operation. Okay, then dress up. Dress up is related to thicken command and fillet command. So there are multiple options in the dress up like jumper, draft, etc. Okay, so today from the dress up we are going to talk about thicken and fillet. Fillet we are already used. Okay, sorry. The limitation of feature based modeling. Okay, now let us understand why to use the Boolean operation. Application point of view, your answer is correct. It is used in plastic and casting products. But why to use Boolean operation? Before going to understand that Boolean operation use, let us understand what is feature based modeling. Earlier modeling which were created in Catia, that modeling method is the feature based modeling. Okay, that is what the all nature of software. Even though Creo and NX also behaves the same thing. Creo, NX also have feature based modeling approach. So can anyone tell what is feature based modeling? What is feature based modeling?
We add features one by one by
Okay,
giving
okay,
dimension to them.
and okay. So do you have any experience if any particular plane is get deleted, then what will happen in feature based modeling?
Parent parent child relationship, that
Broke,
relationship will broke, right?
broken, correct. So when you delete parent feature, age or plane, whatever it is, the entire tree will get hampered. You have that experience also. Okay, in NX and Katia or any other software, if you try to delete the first feature, then entire dependent features are get failed. That is what the limitation of feature based modeling. So feature based modeling will always maintain parent child dependency. Okay, then another limitation, if you want to create some complex shapes, I want resultant bodies of two different bodies or two different features. Fronts, if you look it from front side, it will see a different thing. From top side, it will be shape, different shape. In that condition, it is failed to create feature based modeling. Okay, complex shapes cannot be fully defined. It's quite hard to define that complex profiles or complex shapes, I want to say. So that is what the limitation. Next is part modification become complex due to dependency, because the first point, just like a first point, it will maintain always parent child relationship in the feature based. If the parent is deleted, then definitely the child feature is get deleted. Okay, so modification become complex due to dependency. And let's imagine you are working as a design engineer in industry and you are working on specific project. Okay, in that project we are creating some component over there, a lot of components, thousands of parts for assemblies will be there in the actual industry. And if you imagine in one single part, take any product, let's say an engine, and you want to design the engine crankcase. The crankcase have a lot of features in it, thousands of features will be there. And if you try to delete anything parent feature, then you will get confused. Some dependent features are deleted, and how to rectify that, how to find specific child feature, because my tree or design tree or specification tree is quite very lengthy in that situation, because we are building thousands of features. So in that situation, the modifications create a complexity. Modifications is quite complex to rectify the problem where it is exactly fail after some modifications. Okay, so that is what the limitations of feature based modeling. Complete design plan or intent should be ready to avoid the failures. Generally the failures of features, if the thousands of features are available in your model tree or specification tree, and you are creating the model randomly without any proper plan or without taking intent study, if you have designed anything else and some features are get failed, then it is very hard to identify which feature is failed if you use a feature based modeling. So for feature based modeling, it is required to design a plan. Okay, so your design plan should be ready, or design intent should be ready. What is intent? Intent means planning for the feature building. Do you want dependency or do not want dependency? That initially you have to decide it. Okay, so this is what the limitations of feature based modeling. Then how Boolean operation will get benefited to you? That is what advantages of Boolean operation. What is the need of this Boolean operation? So modification is easy without failure of any feature. Modification is quite easy without failure of any features. At any time randomly you can delete any feature, you can add any feature, you can modify the thickness without any failure of tree, because Boolean operation is complete independent methodology. Okay, next, capable to handle design complexity. Capable to handle design complexity of plastic and casting component. That is what the application. It is generally used in plastic and casting products. Okay, because plastic and casting components have core and cavities on there. So it is very helpful to design the products using Boolean operation such as plastic and casting. Okay, so we come back to the assignment. This is what the assignment. Take a screenshot of this assignment. Take a screenshot of this. If it is over, give reply, give some reactions.
Done, sir.
Okay, almost all of done. Okay, so first command in it, Boolean operation is a add. Okay, so let us understand. Add is nothing but comparison point of view. If you know that add command, it is a similar kind of unite in an X. Okay, so two bodies you want to join or unite it, then you have to use the add command. So as per our drawing, you refer the drawing also. I'm going to solve that assignment now. I open Catia software. Are you able to see? Just check the software Catia.
Yes, sir.
Yes.
Okay. So can you tell me what is the name of this part?
Soap case.
Yes. So you have to go to the part design and give the name SOAP, soap case, and ensure that this button should be off and click on OK. With our regular step, you have to hide this plane by right click in hide option. Go to the first apply this fit to all option so that your orientation will be appropriately matched. Then go to the insert, select here axis system, current off. Okay, that is our regular practice. So now remember that during Boolean operation, do not work on default part body. Just follow my instruction. In the next class of the Boolean operation, I will tell you what is the reason behind it. Why should I do like that? Okay. So do not work on the part body, because part body, as you know, you cannot delete, just like the plane. We are never working on plane. Similarly, for Boolean operation, we are not working on the default part body. If it is a feature based modeling, that is fine. You can go to the part body and apply the feature step by step. But if it is Boolean operation, do not work on the part body, because this body cannot be deleted, and the Boolean operation during Boolean operation, the part body cannot be removed because it is a default. Okay, so what to do for this case? You know that how to introduce the bodies. The last few couple of sessions, repeatedly I inserted some bodies. Okay, so similarly I used again the same concept here, insert option and click on the body. Okay, and for this body I will give this name. Click on the property, feature property by right clicking option, and give the name base body, bb, base body. Here we have to create the first feature. Okay, some guidelines of Boolean operations are there, but that detailed guidelines I'm not going to conduct today. Just understand the logic, and in the next class I will tell you do's and don'ts of Boolean operation. Clear? So now in the base body, so first feature from front view, if you see, do you have that drawing? Can you able to refer that drawing? All of you. Is it possible to refer that drawing simultaneously to all of you? Okay, so please check the front view there. In the front view, I observed three arcs. Can anyone tell the radius of that arcs? See here, this is that radius R90. This radius R30, but it is instead of R, directly height is given. Fine. And this total length is 151. So you have to plot these shapes closely first. From which view? From front view. So I'm going to open that software. And which one is the front view here? Why is it? Take sketch and draw the profile over there. I don't need this access system for the sketch purpose. I just off it, hide and show option. Okay, so display of access system is hidden now. And create the profile. First create an arc. Draw circle. Then select this circle, use mirror with respect to this vertical center. And then one more circle is there. Which is directly tangent to these two circles. Okay, so let us do that. This circle and this circle, right click, tangent. This circle, right click, tangent. This center point and this horizontal reference should be coincidence. After that, that radius. Before creating that radius, I'm going to create a line. If you see it from top side, there is a 34 mm distance. There is a horizontal line. So we plot horizontal line which is matching to the horizontal reference. And now trim unnecessary profiles. So use here quick trim. I don't need this profile. I don't need this profile. Don't need. Is it correct? Yeah. I don't need this. Don't need this. Yeah. And now move this center point in a downward location. So now we are reaching to the rough profile. So if you trim this, you will achieve this shape. Now define the sizes. What size is given? From this to this, it is how much? It is 30
30.
or 30, correct. Then 34 is different size, right?
Yes, sir.
30 is given. After that, R90,
R90.
that is also given. So this is R90. I'm not going to modify any sizes right now. And one more size is given. What is that?
R30.
R30. Yeah, R30 is given. So R30 is given here. So it is not necessary. Already we are put it that height here. Okay, redundant dimensions.
Length.
Okay, now which length is there?
Upper length.
151, correct? So define that this length. Okay. And now all sizes we will change simultaneously. How? Using this command, edit multi-constraint. Simultaneously all sizes we can able to change. If you try to change this one by one, the profile get disturbed. If you try to see here, this radius is 90, then profile get disturbed. Proportions is get disturbed. So I go back using Control Z and use this option of edit multi-constraint option. So first this length is how much? Can you tell? 151. Enter. This one is how much? This radius is 90. Is it 90? And this one is 30. See the preview. Click on OK. My first profile is completed. Let us check. One more size is given. 70 is matched or not. From the center point. Okay. So this point to this one, right click here, horizontal dimension. It shows you that it is 75.5, but I want that point at 70 mm distance. Correct?
So the horizontal line is little extended on left side.
Horizontal line. Hello.
Is little bit extended on left side in the diagram.
Just a minute. In the diagram. Okay. Horizontal line is not from this. Fine. So 151 is a total dimensions actually. So from this one, it is not mentioned. So I'm not giving that 151. You are correct. We are going to delete this. Okay. So what to do? Double click here. Uh, that size is 70 is mentioned. So from this point to this point, right click and make them horizontal dimensions. Now it is correct, right? This is 70. Now check the status here. Sketch solving status. It show ISO constraint. Geometry is closed. Okay, and exit this sketch. Now in this first base body feature, sketch number 1, we have to add a material to it at how much distance? The distance of
120.
120. So let us check once again, is it 140 or not? Yeah, it is 140. Okay. So exit the sketch and add a material the distance of 120. So how much should I give here value?
60.
60, correct.
Mirror
And this
extend.
become mirror, correct.
Right.
Okay. So first feature is get ready. And then second here you see there are some rounds at this sharp edge. How much that radius of round?
15.
It is 15. So you put that radius using fillet option. Where you find that fillet option? In the dress up tool. So here is that dress up. In the dress up tool, you will find this edge fillet. So select this edges. Here how much that radius 15 is given. So press this value, enter this value and click on OK. Okay, my first body is get ready. Now on that body there is one more rectangle. If you look it from front view, you will observe some height here. So can you tell how much that size? Where you can see that details of that. Here the details C.
Details.
You will find its height. How much? 1.5. So what to do? And offset is how much? Total thickness, can anyone tell from detail view? Total thickness is how much given? It is given it is 3. If it is total 3 and 1.5 from this distance, then remaining distance will be how much? Again 1.5. Correct? So we'll do that, the profile. So for that purpose, introduce one more body here. And here I give the name of that body BB2, base body 2. Add to this axis system. Okay, but what's the problem now? When I introduce this body, automatically the previous body display will be hidden. That is because of in the tools toolbar, you will be finding this only current body option. You can off it. Okay, so you will be see all body at a time, but you want to see only working body. Those you are working, that body you want to see, then active this button, only current body. Okay, because nothing you are creating base body 2, that's why nothing is displayed, and whatever the previous bodies are there, that will get hide. So we want to display for reference purpose previous bodies, then active this only current body. And how to active the bodies? By right clicking on the body, use this option, define in work object. Now in the second body, I am going to create the next feature. Okay, so click on sketch. Do not take the faces for the Boolean operation. Do not take directly body faces. Always take the planes. Because if you take this face, again the parent-child relationship will come. And during Boolean operation, it will get fail the features. So to avoid the failure of feature, it is mandatory to take the references as a plane, point or lines. So do not take the reference face of previous bodies. Otherwise, relationship will build it up. So you take this plane again and make it to first quadrant. Okay. Now you have to create here the profile and the distance of offset distance of 1.5 if you see from detail C. So how to take offset of this profile? If you go to this, you will finding here transformation feature. In that you will see offset option. Click on offset, select this entire profile And if you move the mouse accordingly, your direction is get adjusted. Okay, so first you decide the direction whether you want inside profile or outside profile. I need inside. At the distance of how much? 1.5. So you first make it active that offset option and go to the inside direction, mouse location first, and define this value to 1.5. Okay, but here you see this is the yellow edge. Hello,
The object
hello,
object will be
your sound is not
creating
clear.
parental relationship.
Hello, your sound is not clear. It is cutted to me. I can't hear you. Can you put the chat? I repeat this. Somebody says instead of offset, I can create one more profile. That is also fine. You create a rectangle there and define the dimensions. That is also fine. But if I try to use this offset option, offset will create parent-child relationship. Yes, correct. That I'm going to tell you, Suraj. So if you use this offset option and select this, and that distance is 1.5. Here you see this age is a yellow. It means it maintain the relationship with the previous references. Okay, so that I don't need. So how to break that reference relation? So for that, use this sketch analysis option, select use edges. So here you can understand whether I create the previous references bodies or not. So to check whether I use the previous references or not, use this option of use edges. This use edges tab here, this option should be blank. So I need to isolate or break the linkage with the previous body using this button. Isolate geometry. Click on this isolate geometry, and then you can see this is the complete blank. Now relationship with the previous body is not there. Okay. Now give the relation dimension constraints and geometrical constraint. As usual, all profiles are tangent to the arc. Everywhere it be maintain the tangential relationship for the arcs, and instead of giving the dimension, so suppose if I give the dimension from this edge to this line, again the problem will come. It will maintain the previous body relation. Try to check it here. Use edges. It's showing you are using the previous body references that I don't need to use. So hence I delete this geometry. I don't want to use that reference. It should be blank always in the Boolean operation. So I close it and define the sizes from here. So from this vertical dimensions to this. Okay, always provide the obsolete reference dimension. Otherwise, what to do? I'm going to exit this. You introduce one more plane here. From this reference, how much total length is there? It is 140, right? So half of 140, I define this dimension 70. Now you go back to the sketch number 2. You will finding this reference. You can use this reference plane, but never use the reference of previous bodies. So now I give the dimension from this plane. I just zoom it. Are you see this plane? All of you? I think now you can. Now it is fine. You see this plane, right? So from this plane to this line, you can give the dimension. Plane reference is fine. You can check it here. It is a reference you are using, but that is a plane reference, doesn't matter. It depends on reference plane, but not depends on bodies. Okay. Similarly, from other sides also, we can introduce the planes. So I exit here and apply the plane here. So that plane at the distance, how much it is? 120, na? So this becomes 60. Other side also I apply this plane, the reverse direction. Again, this plane in the reverse direction, it becomes 70. So from all four sides, apply the reference planes. You go back to the sketch and define the dimensions from that reference plane. It is fine to add it, no problem. So this line become vertical, this line become horizontal. Okay, this to this 1.5, this to this 1.5, this is radius automatically comes, no need to modify. Okay, now you check the status. It should be ISO constraint, but now it's showing under constraint to you because of tangential relation is not maintained here. So this become tangent. Now you check the status, it shows ISO constraint and your geometry is closed, and in the usages we are using the previous reference planes only. Okay, now close this. I will exit this sketch. Now I'm going to add, just for easiness purpose, I will hide these planes, add a material to it. Where to add? In the base body number 2, using defining work object, select this part, sketch number 2. What height is given in the drawing? See the sections detail, see it is 1.5. 1.5. So I'll do that 1.5. Click on OK. We can see that. Okay. Now this body is different. This body is different. We can see that this is different body. This is different body. Okay. Now you have to add this body in this base body. How to add? Simply use Boolean operation tool. So to active the Boolean operation, just drag this option, Boolean operation tool, and use first command in it. What is that? Add. Just expand this drop down list. This is the first command, which is the add. So what to do now? Select this command, base body, one dialog box will appear. What to add here? That you have to select. You have to add base body. Where do you want to add? In the BB body. And then click on OK. Okay, now these two features are get merged with each other. Okay, there is alternate way also. I'm going to delete this bad. So instead of this toolbar, direct option is also available. Simply right click on the base body. Listen carefully, all of you. Select this base body. Right click on it. Base body object. Here you will get the shortcut options of Boolean operations. So I want to use the add. So I select the add option. Where to add? In the base body. Do not add anything in the part body. You simply hide it. Similar kind of default planes. Do not work on it. Okay. Now after adding this, there is one more feature. First, I will save this file in your day number 7. Catia online, day number 7. Okay. Now what is the next feature here? There is one more addition. You are finding these 4 legs for the resting purpose. There are 4 legs, or the boss you can say. The diameter of that legs is how much? Can you tell? So this one is that. What is the diameter? 510. Diameter 10. At what distance? What distance? 34 mm offset distance. So what to do? Hello? 34.
22 and 20.
So what to do? You use the plane. So select the plane here. Okay, so from this plane at the distance of how much? Reverse direction. Distance 34. Am I right? So you simply give the name here for this planes property. This is the 34 size, 34 mm, just for identification purpose. Why that plane is not displaying to you? Because only current body is on, so you have to off it. All planes will be active. So here you have to design that circles. So what to do? Insert the body now. The body number 4, I give this name here, property bb3. In the body number 3, create the sketch on where the plane of 34 mm distance, reverse direction. Okay, now draw a circle, diameter is 10. Draw a circle. I'll active the only current body option on. Just a minute, where is that tool? Yeah, okay. So something here at this location. What is the diameter? 10. So define that size 10. What is the location? 20 by 22. Am I right? So 20 from this plane. Do not take this line. Do not take this line because we are taking the previous body reference. Do not take bodies reference. Always take the planes or axis reference. So I'm taking this plane to this point. That size is how much? 20 or 22? 22, I think. Right? So this become 22 here, and one more reference is 20. From this plane to this point, it become 20. Now you exit this profile. Before that, before going to exit, always make some habit to check whether it is correct or wrong. So use sketch solving status. It show ISO constraint. It is fine. And geometry should be close. In usages, we are using the two reference planes. That's fine. So we exit the sketch here and add a material. Add a material. So what is the direction of material? Upward or downward? Upward or downward?
Upward.
Upward.
Upward. At what distance? At what distance?
Up to next.
Up to
Up to
next. But here if you see, up to next is not possible because in this body you will see there is nothing in it. For reaching up to next, there is nothing getting to the software from where you can add the material. So what to do?
Until next.
No, you can't use until next such options. Only one thing is that you use this some dimensions, set of dimensions,
Take a random
set of
value.
dimensions. Okay, get some values there, 50, 20, whatever it is. It should be merged appropriately. I'm taking 15 value. It should be appropriately merged. And then you can see that. Okay, so if you check here, only current body, this is what the boss or the resting pad. Now, this body need to be add in the base body. So you simply right click on it, shortcut option, select on add option. Where to add? On which body we have to add? This base body, correct? BB body. Okay, now that is get merged. That's why you will find this edge. But one more addition is there. There are 4 instances, correct? So I'm going to delete this add and apply the instances first. What to do? Use a pattern. Instead of creating 4 bodies, use a pattern and do not select any feature because you want to pattern entire body. So you say here current solid and direction of pattern is which one? Y. Which current solid is base body 3. First we have to active this and then use the pattern. Now the direction of pattern is Y, along Y direction, but reverse. The distance is how much? Spacing is given, I think. this center to this one, it is 80, correct? 80 along y direction, the spacing is 80,
100,
100 or 80.
100.
100.
Okay, 100, fine. So this become 100. And in second direction tab, select the direction number 2 here along x direction. Quantity I need here 2, and what is that spacing? Tell me.
76.
Huh? How much?
76.
76. So you define that spacing 76, but it should be reverse. Preview and click on OK. So these 4 instances are created. Right now you can right click here and use add to base body. The bodies get merged, and because of merging you will find here age. Okay, so all additions I think are over. Now we are talk about a core sites. Core sites. So to create a course,
One more addition is there.
which one?
Add hook type.
Which one? Your voice is breaking.
Detail F, detail C.
In the top view, we can see the
In detail C. Okay. So if you see here, what is detail C? Is it matching or not?
detail E. Detail E.
Detail E. Where is detail E? Yeah, detail E. Okay, detail E I will tell later, because there is one more command to tell, that is intersect. While coming to that point, I'll tell you how to do that. Okay. After that, you produce